Hello everyone, and let's have a quick look at this question. So it says the gradient of the curve is given by the curve passes through E1, and find the equation of the curve, giving your answer in this form. Okay, now first of all, you got differential equation there. You need to separate these. Okay, separate the variables. So you want the dx on that side, and the dy's, anything on y going on that side. So just to save space, I'm going to rewrite this, multiplying this e to the 3y to the left hand side. So you get e to the 3y dy, and that's going to equal this side, which is going to be 3x squared ln of x dx. Okay, and also I'm going to, because now I've got the variable separated, introduce my integration. Okay, cosine. So this side is fairly straightforward to integrate. Any exponential function, when you're integrating it, stays the same, so that will just stay e to the 3y. But when you differentiate this, okay, you're going to also differentiate the power. So when you integrate into reverse, you're going to divide by the differential of this power, which is a third. Okay. And when you're adding c, you only need to add c to one side, so I'm just going to add it on the right hand side when I've done that bit. So that's there, done. That's easy. So that is basically, if you want to double check it, that stays the same. Differential of 3y is 3. When you times that third by a 3, you'll get e to the 3y. So that's all good. Now here it's hard. It's a bit harder to integrate this side because you've got a product, and because it's a product, you have to do parts here. Now normally you would call u x squared or anything with x, but if you got ln, you tend to call u ln because it's easier to differentiate this. Okay, so I'm going to call u equals ln of x, and I'm going to call dv dx 3x squared. So du dx is going to equal, well, when you differentiate log, it's just 1 over x, or ln, sorry, it's 1 over x. And when you integrate this one, v is going to give me, I don't want to power shared by 3, it's just going to give me x cubed. Now, I've still got 1/3 on this side, so that's 1/3 e to the 3y. And on this side, you're going to get uv, so that times that, which is going to give me x cubed ln of x minus integral v du, v, which is x cubed, du, now that's going to be 1 over x times dx, 1 over x dx. Okay, now let's use a different color pen because I'm doing a bit of cancellation here. Now here, that will cancel with one of those, so that will become a 2, and that will disappear. So what we end up with, we get 1/3 e to the 3y equals x cubed ln of x minus, now you just got to, that's gone, so you integrating x squared really. So when you integrating x squared, you just get add 1 to the power, which is 3, divide by new power, okay, and then you can just plus c. Okay, that's all right. So this side is done. Happy days. Now, okay, well, I can get rid of this 3. I can times everything by 3, so I'm going to get e to the 3y equals 3x cubed ln of x. That becomes x cubed. That becomes 3c. I'm just going to call it k. It's still an arbitrary constant, so it's no problem. Now, you've been told that the curve passes through this point. So this is x, is e, when y is 1. So let's just sub that in here. So y is 1. 3 times 1 is just 3, so that's going to give me e to the 3. That's going to be 3 e, x is now e, so that's going to be e cubed ln of e. Now note that you should know this, that ln is the same as log to the base of e. Okay, so when I put ln of e, that's going to be log to the base of e, and you should know that if the base is the same as this number here, okay, that is going to equal to 1, because it inverses each other, they cancel. So therefore they're going to cancel, over there, and that will be minus, and that e will become e to the power 3, because x is 3, so that'll be e to the 3 plus k. Now what you end up here, you get 3 e cubed minus e cubed, so that's going to be 2e cubed. Now take that to the sides, will be 3e cubed minus 2e cubed is going to equal k, and therefore k, the arbitrary constant here, is going to equal to minus e cubed. Okay, let me just put a dividing line down here. So now, as required, I can write down my equation in this form. So I know that, going back, writing it here, I know that e to the 3y is going to equal 3x cubed ln of x minus x cubed. This time k is going to be replaced by minus e to the 3, and that is my answer in this form. Okay, so it's e to the 3y in some function x. Now the next part it goes here, show that when x equals e to the 2, the y coordinate curve can be written as this. Okay, y coordinate of this curve can be written like this, where a, b, c are constants to be determined. Okay, so simply we're going to sub in this into this equation. So I'm just going to choose a different color here. Do like my colors. So put says we need to find y, so e to the 3y is going to equal 3. Now x is going to be replaced by e to the 2, so that's going to be e to the 2 cubed ln of e to the 2 minus e to the 2 cubed minus e to the 3. Now note here, just like here, if you got ln of e, you just cancel that out, and that just becomes times 2. So you're going to get e to the 3y equals, that's gone, 2 times 3 is 6, and multiply the powers will give me e to the 6 when you cube that. Similar reason here, that gets cubed, e to the 6, and that is minus e to the 3. Okay, and if we simplify that, not taken away from that, you're going to get e to the 3y equals 5e to the 6 minus e to the 3. Okay, so now let's have a look what we're going to do now. What we can do here is factorize that. So you're going to get e to the 3y is equal to the e to the 3 out, open bracket, you could get 5e to the 3 minus 1. So keep an eye on what we want in this form. Okay, it's always a good idea to look at how we get in there. Okay, yeah, looks like we get in there. So what we can do now to get rid of the e, we natural log both sides. It's telling you it wants a natural log in there. If I natural log the left hand side, and then natural log this side. Now don't forget, I'm going to natural log all this product. Okay, so what we do here, again, yeah, I'm going to use a different color now. So if we cancel, ln will cancel with e, so that would just leave me as 3y. Now here we can use log rules. Okay, I'm going to run out of space, so what I'm going to do is add another divider down here, and then move that up. So log rules means that if you got a product, that becomes an add when we separate it, so that becomes ln of e to the 3 add ln of this bracket 5 e to the 3 minus 1. Keep an eye on what it wants. So we're getting something like that, what it's asking. Okay, good. So we'll write this next line here. So we're going to get 3y equal to, now ln and e, they will cancel, so that will end up with just 3 on this side, plus ln of bracket 5 e to the 3 minus 1. Okay, keep another eye on there, we're almost there. So we want a third, that third is going to come by dividing this all by 3. So y will equal, divided 3 divided by 3 is 1, plus that divided by 3 is the same as timesing it by a third of ln, open bracket, 5 e to the 3 minus 1. And that's exactly in that form. Don't be phrased by this plus c, it just means c is a minus 1. So still a constant, and that is it, I think. Yeah, I'm just double checking we're okay with that. Okay, in that form, and yeah, that looks good to me. Ready to go. Okay, hope that helps.